Planetary gearing is a gear system that consists of one or more outer gears, or planet gears, revolving around a central sun gear. Usually, the planet gears are mounted on a movable arm or carrier, which itself may rotate relative to the sun gear. Epicyclic gearing systems also incorporate the use of an outer ring gear or annulus, which meshes with the planet gears. The sun, planet carrier, and annulus axes are concentric, and the axes of the gears are usually parallel to each other. The advantages of a planetary gear over parallel axis gear are compact size, higher efficiency, and low noise level. The planetary gearbox arrangement also creates greater stability due to the even distribution of mass and increased rotational stiffness. Disadvantages include high bearing loads, inaccessibility, and design complexity. Also, it is harder to find the reduction ratio in the planetary gear train than conventional gear trains. In this animation, we present a planetary gear system made up of 8 gears and 1 carrier arm. The number of teeth on the green annulus gear is 96. On the yellow planetary gear, it is 24. On the planetary gears, it is 48, and on the blue sun gear, it is 24. Notice that this planetary gear is made up of 5 sections. First, let's turn off all the section selectors. Now, let's turn them on one section at a time. The first section shows the cross-section of the input shaft. Here, the red line shows where the section has been cut. The second section shows the green annulus ring and yellow planets. The third section shows the carrier arm on which the yellow and red planets are attached. Notice that the input shaft is directly connected to the carrier. The fourth section shows the red planets and the blue sun. Notice the red and yellow planets are attached to the same shaft and rotate at the same speed. Also, this connecting shaft is mounted on the carrier and rotates with the carrier. The fifth and final stage shows the output shaft. The small white circle on the blue sun and the large white circle on the carrier will help us to find the rotation ratio of the output shaft to the input shaft. We also show a graphical representation of this planetary gear mechanism. The gear ratio of the output at right to the input at left is given by the formula shown. The color and the character R, G, B, and Y shows the number of teeth on the red, green, blue, and yellow gears. If we substitute the previously given teeth numbers, 96, 24, 48, and 24, into the equation given, we come up with a speed ratio of 9. We can see this by counting the total number of rotations the small white dot makes during one revolution of the large white dot. Count the rotation. As you can see, that the rotation is 9. This concludes our presentation of a planetary gear system.